So, in summary, we did an extensive set of measurements. We worked very closely with Sun and ITI to improve the image quality using the digital web press. Pinning, actually, I mean, it's not a new concept, but what's going on is that you're really affecting the viscosity of the ink. You're going from an almost water-like jetted ink to a more viscous material, not fully cured, but arrested in its spread. And that's actually something you can control by using the LED intensity level. We looked at two different wavelengths, 365 and 400 nanometers, approximately the same output, monochromatic intensity. And it certainly adds value in terms of drop spread on primed coated paper, and that increases the flexibility of the press. But it's also useful as a tool to control the wet-on-wet behaviour of the ink on a wider variety of substrates. And it provides another degree of control. So in terms of the actual image quality, what people see and buy is the critical thing, is the most critical of all. And the LEDs really have shown to give an extra dimension of control, which is certainly useful in this product. A couple of references there in terms of the oxygen inhibition effect, also in terms of photoinitiators, two excellent papers about that. Thank you very much for your attention.
Thank you very much, Andrew. Do we have any questions? Please.
Could you make some comment about the effects of pinning on interlayer adhesion, and also have you done any work with it in a scanning mode, and what is the effect of the pinning on bidirectional banding?
The answer to the final question there is no. We haven't done any work, well, certainly not to be published at this stage, on bidirectional. I believe that the macross banding I think we're talking about can be affected, improved by pinning. And I've forgotten the first part of your question.
The effects, did you study the effects of the interlayer adhesion?
Well,
the different layers?
The answer to that is no. It would be very difficult to do so because you're really at an interim stage. You're taking the ink from a almost water-like viscosity to a slightly higher viscosity, which stops it moving around. Then you've got the final cure. So, in terms of adhesion, it hasn't reached its full adhesion properties with the substrate. You've just really stopped it moving. So, adhesion at that point is not really something that you can measure or improve.
I mean subsequently, after you do the final cure.
After the final cure?
Comparing pinned and unpinned.
In terms of adhesion?
The interlayer adhesion.
I'm not sure what you mean, because
cropping or abrasion resistance.
Well, the ink is fully cured by the final cure. So we certainly don't see any effects after the final cure that would affect adhesion.
Could you comment on the highest available power densities of LEDs that we could achieve at the moment, and predict where they will be about 12 to 18 months from now?
Well, in terms of intensity levels, we're operating at the sub-watt level, but I don't think power is the whole story, certainly not in terms of pinning. I think you're trying to...
Not pinning, full cure. Talk about full cure.
Oh, full cure. I don't think that we're going to see full cure taking place in oxygen from LEDs, free radical inks, without using massive numbers of LEDs. for quite a long time. That's simply an economic justification, because LEDs, you know, one can easily assume that LEDs are cheap because they're all around us in all sorts of instruments, but UV LEDs are definitely not cheap, and a lot of them makes for a very expensive product, which actually you could achieve a much cheaper result just by simply using conventional mercury. So I don't think we're going to be seeing full curing from LEDs for quite a long time in the presence of oxygen.
Okay, one more question, please.
For to answer that answer, Sun LLC and Nova Severus is doing full LED curing with wide format APET. I spent a week there. I flew a module cost $16,000, and they exhibited at SGIA. Also, Summit in Indiana is doing full LED curing with LED. Both are using LED on the carriage. The Sun module is fairly good size. The Summit module is a lot smaller.
Is that free radical link?
Yes. I know it's free radical link with Sun because I asked them and went to their ink lab. And we have a full report on it, a law report, free download.
I hear different stories about what that ink is.
I've heard, yes, someone has asked me if it wasn't really, you know, cationic or something. I asked Sergey and he assured me that it is free radical. I can check with him again. But people that asked me the same question, they're unsure. They also said they were unsure who really made the ink. And he said that they make, I know they make ink because I've been to their ink factories at a Russian military base.
Well,
for sure it's free radical. It's free radical, for sure.
The sunflower ink, that's what they told me.
well, that gives hope for us.
And they're looking for partners. They'd be very glad to partner with you and interact with you in any way.
Okay,
Thanks a lot.
thanks very much, Andrew. Moving on now to looking at the ink perspective, we have Mark Bale, Technical Manager from Sunjet.